Hey guys, welcome back to my channel. In today's video, we're going to see how to solve this problem called relative ranks, right? So it's a LeetCode daily challenge for today. So let's read the question first of all. You are given an integer array score of size n, where score of I is the score of ith athlete in a competition. All the scores are guaranteed to be unique, okay? So the athletes are placed based on their scores, okay? Where the first place athlete has the highest score, the second place athlete has the second highest score, and so on. And the placement of each athlete determines their rank. Okay, so basically there are some scores, so we have to give them ranks, right? So the rank will be something like the first place athlete's rank is, then for the second place it is silver medal, and for the third place it is bronze medal, right? And after that, that is from fourth place till the nth place, the rank of each athlete will be X. What is X? X will be the position of that, right? So let's say an athlete is having a position of X. Let's say the rank is 5th. So we will just simply write 5 in that case, right? So let's go through the examples. So 5, 4, 3, 2, 1. These all are the scores, right? So these all are the scores. So what are their ranks? 5 will be having the gold medal. Why? Because 5 is the highest number, basically the highest score, and 4 is the second highest score, right? So second place athlete is having rank silver medal, right? So we will simply write silver medal, and then comes 3, right? 3 is the third highest value. So bronze medal will be given to 3. And then after that 4 and 5, right? So let's understand the question once again. So these all are the players, 1, 2, 3, 4, 5, and these all are their scores, right? The scores are given, and then we have to get the ranking. How? See, here 10 is having the highest score, so he will be securing gold, and then 9 is having the second highest score, so he will be having silver, and then 8 is having the third highest score, so he will be having bronze, right? So for these scores, we will just give their rankings, right? So from here, we will get to know the rankings. So for 10, it is gold. For 3, it is 5th place, right? So what did I say? Apart from these three, whatever comes, we are just going to write the position, right? So 3 is in the 5th position. So I will be writing 5th. Or let's remove this. I will be writing 5, right? And for 8, 8 is having bronze medal, so I'll be writing bronze. And for 9, 9 is having the silver medal, so I'll be writing silver. And then for 4, 4 is having 4th position, right? So I'll be writing 4, right? So that's how you're going to generate the answer. So how to find the rankings, right? So we just try to find each of their ranking, right? So can you think in some direction, like we are just sorting it down in a decreased way, and then we are getting the ranks, and also what we are doing this, we are just sorting it in, descending order, right? So that's what the thought process will be. So after sorting it in descending order, it is very easy to get the answer, right? So to solve this, you can either go for max heap or sort, right? So first of all, let's look into the max heap. So in the max heap, what I'm going to do, I'm going to push all these elements into the max heap. So after pushing this, elements will be in this order. So what I'm going to do, I'm going to pick up the maximum element from here. So the topmost element will be the maximum. So I'll be writing it, and then I'm going to remove this. And then I'm going to pick up again the maximum element, so it will be 9. Then I'm going to remove this. Then I'll pick up this, it will be 8. Then I'm going to remove this. Then I'll pick up this, it will be 4. Then I'm going to remove this. Similarly, I will pick up 3 also, and then I will remove this 3, right? So I got these values in descending order. But what I'm doing, I'm keeping a track of count also. So at first count will be 1, and the moment I got the first element, I will say, bro, the count is 1. Then I will increment the counter and I will get the second value. So the 9 will be having the counter 2. Then after incrementing, I will get the third value. So 8 will be having the counter 3. Then after that, 4 will be having the counter 4. Then 3 will be having the counter 5, right? So I will store the same thing in a map data structure. But I will be keeping one more thing in mind, that bro, these three, right? These three are not 1, 2, 3. These are gold medal, silver medal, and then bronze medal, right? So I will handle these three separately, Then for the rest of them, I will just assign the value of count, right? So let's look into the code right now. So the code is pretty simple. I'm keeping track of the map that is from int to string, right? What is int? Int is basically the score, and this string will be the ranking. Then I'm using a maxip, then this thing, right? So this thing we are going to use it later on. So first of all, I will just iterate through all the scores, and then I'm going to push them in the maxip, and then I'm going to iterate inside this maxip, and I will check whether the count is 1, 2 or 3. If they are, map of this top element, right, that is pq.top is equals to rank of rank index. So rank is this, rank index is count minus 1. Why I have written this? A gold medal is in the index 0, then silver medal is in the index 2, and bronze medal is in the index 2, right? But the ranks are 1, 2 and 3. So can I say rank minus 1 will give the index? Right. So rank minus 1 will be the index, that is count minus 1, and then I will assign map of this top element equals to a rank of rank index. So this part is for first, second and third, and for the rest of them I will just simply take the topmost value, and then I will convert this count into a string and then store it. Why? Because see, for the rest of them we are storing the position, right? So count will be storing the positions. So I'm just going to convert it into a string and then store it. But at the end, we have to return in vector of string, right? So I'm just going to iterate in the score, and then I'm placing the rank of that particular score inside this answer vector, right? After that, I'm just returning the answer, right? So what about the time complexity? Time complexity will be of n log n in this, n log n in this block. Why? Because see, we are actually processing the max heap, right? So it will take log n. So this loop will go for n. So it will be n log n time, right? So here also it will take O of n, and then here also it will take O of n. So it will be O of n log n, right? So what about the space complexity? I'm using a map. It will be taking O of n space and then a priority queue. So it will be taking O of n space. So the space complexity will be O of n. So now let's have a look at the second approach, right? So the second approach is by using sort. So in this, I'm not going to use any priority queue. Instead, what I'm going to do, I will store it. I will store it in some vector, let's say called sorted, and then I will just sort this vector, right? So it will be having 10, 9, 8, 4, 3, right? So these all are the indices of this sorted array. And can I say the ranking will be like this 1, 2, 3, 4, 5, right? Why? Because they are sorted in decreasing order, right? So this ranking is basically index plus 1. See, in the 0th index the rank is 1, in the first index the rank is 2, second index the rank is 3. Similarly, for the ith index the rank will be I plus 1, right? So the ranking will be the index plus 1. And after that we are going to map the score to their ranks, right? So 10 will be mapped to 1, 9 will be mapped to 2, right? So 8 will be mapped to 3, then 4 to 4 and 3 to 5. But again, we are handling these three cases separately because first place should be printed silver medal, and for the third place it will be bronze medal, right? So index from 0 to 2, I'm going to give something like gold, silver and bronze. And for the rest of the indices, I'm going to give rank index plus 1. And after that, I'm just going to iterate through this original array, and I'm just replacing this score with their rank, right? This score with their rank. So how I will get to know the rank? From this map, right? So from this map, I will take the ranks and then I will generate the answer, right? So let's look at the code right now. So I'm maintaining a map, and then I'm just making a duplicate array of scores into a vector called sorted, and then I'm just going to sort it. So this part will make sure that they are sorted in descending order. And then similarly, I'm going to keep track of the ranks, gold medal, silver medal and bronze, which will be used later. And after that, I'm just going to iterate through all the elements in the sorted array, and then I will check if it is 0, 1 or 2. If the indices are these, map of that particular score will be the rank of I, right? Rank of 0 will be gold medal, rank of 1 will be silver medal, and the rank of 2 will be bronze medal. Else, if the I is greater than or equals to 3, 4, 5, and so on. For this, I'm going to say, bro, rank of this score is I plus 1. That is index plus 1, right? And after that, I'm just going to generate this answer by traversing through the score, and then I will get their ranks, right? So this will give their ranks. So after that, I will just simply return the answer. So let's have a discussion on the time complexity, right? So this sort function, it will be taking of n log n, right? N log n time. And then this loop will be taking of n time. This loop also will be taking of n. So the time complexity will be of n log n. And what about the space complexity? I'm using a map and then I'm using a sorted array. So for both of these, I'm using of n space, right? So of n space I'm using. You can write it like of 2n also, because we are using a map and also a vector, right? So that's it for the video. If you like the video, hit the like button, subscribe to my channel. Until next time, see ya.